And when we say science, we just don't apply the science. Otherwise, anybody who has an algorithm can go ahead and become a data scientist, right? So there's a huge component of art also involved, right? So when I say art, that means exactly the same data, exactly the same tools and techniques, and you'll see two different analysts come out with two different results, right? So that's where you have to be really applying your art and science together with the data to take the business, or I mean, to derive the business impact, right? But that is not the only ingredient. What is also needed is the business knowledge, right? So you should be knowing what exactly it is that you're actually trying to solve for, right? So let's say you're working in a telecom industry, and your client says that I have to really figure out why is it that my customers are attriting or leaving the company and going to some other telecom provider out there, right? So that's where your business knowledge and the context and little bit of the business understanding is going to be important. You really cannot be blindly looking to the data and looking into the algorithms and tools and techniques without paying attention to the business and what are the drivers, what are the objectives, what are the things that you should be aware of, what are the boundary conditions, what are the constraints, right? So that is the main purpose in having the business knowledge. And ultimately, no matter how good you are as a data scientist and what you do, ultimately, you will be known for the business impact that you're going to create, right? So whether it's the increased revenue, whether it's the lowering of the cost, whether it's the improved customer satisfaction, employee satisfaction, right? Whatever, I mean, n number of objective functions could be there. But ultimately, you will be gauged on how well you have created that business impact, right? So if you do this very well, you do this very well, but you're not able to get the business impact, probably you're not going to be very successful as a data scientist, right? So that's what basically the crux of the entire field is all about. And do we take a question now, or we take it?
We can take it in the end, Mr. Pandey.
Okay, perfect. So let's do that, right?
Yeah, let's do that.
Yeah, so we'll take up any questions that you have towards the end, and I will cover my question and pause, and then break up the session for your Q&A, right? So you can note down the questions that you may have. So if you look at the terms which people use within the data science industry, I mean, there are many, many things that people use interchangeably, right? So you may have heard about the deep learning, you may have heard about the machine learning, right? AI, everybody is using AI nowadays, right? Or talking about the AI. And then we have the analytics in data science, right? So this visual sort of like gives you a clue about, how they are all integrated with each other and how they are correlated to each other as well. So AI is the bigger umbrella of anything that you're doing in terms of teaching a machine on how to act and behave and work like a human, right? That's why it's called the artificial intelligence. So the machine is not intelligent. We are making them intelligent by training them, by working alongside with them, and so on and so forth, right? The other term people are using nowadays for AI is not the artificial intelligence, but we call it augmented intelligence, right? And the reason why people call it augmented intelligence is that neither human nor machine alone can do the best possible job as they combine together, right? So you're augmenting a human with a machine or vice versa to really derive the best value out from the data that you're working with, right? Within that, there's a smaller subset of the universe where we call the things as machine learning. So these are the algorithms. Most likely, these are the statistical algorithm or driven by the data algorithms where you train them on the historical data or where you train them on the current data. And then because they have been trained to identify certain pattern, they have been trained to identify certain behavior. Now you can actually deploy them in reality, and then they can actually work to really give you the output that you desire. To give you an example of a machine learning algorithm, right? You would, I'm sure a lot of you would have already applied for a bank loan or would be applying in the future, right? Whenever you go to a bank or any financial institution for that matter, and you say that, hey, I want to get a loan, right? They will ask you certain information. They will ask you what is your CIBIL score or what is your FICO score, right? What is your income? How long you have been working? Which company you are working for? And so on and so forth, right? So all this information in turn is fed into a model, right? A machine learning model where they will know what is the probability that if I give you a loan, you will pay back that loan on time or not, right? So that is the main thing that people are actually looking at in terms of a loan decisioning engine, right? Let me give you another example. When you go to a used car marketplace, right, cars24.com, or a bunch of these sites are there, right? They will ask, what is the make of your car, how many miles you have done. They will ask, what is the manufacturer or the company of the car, and so on and so forth. Again, the information is being fed into a model that will spit out the price of the car that you can expect, right? And the list goes on and on and on, right? You would see that when you go to Amazon, they will say people who bought this also bought this, right? Or when you go to YouTube, they will say the recommended videos for you, right? Or when you are on a Facebook or LinkedIn, they will say these are the friends recommendation or the network recommendation for you. All of these are being driven by the machine learning algorithms, right? I'll give you one live example over here just to really show you, how deep this area is and how pervasive this area is. So just a second, I'll clear up my drawing. Right. So just a second. Remove the annotation. So if you go to news.google.com, for example, right? And I'm just displaying it right now on my screen. So you can see they have categorized the articles in different buckets. So they will say headlines, right? Then let's go on. So they will say for you, depending on my interest, depending on what I have read and so on and so forth. They have a category called India, right? And they have a category called Word. And you'll see local stories, right? You'll see business, all of that, right? So do you think there's a person who is sitting somewhere in Google office and then categorizing the news as they're coming in real-time basis and putting them in these buckets? The answer is no. All of this is automatically being handled by the machine learning algorithms. The moment they find a news bite coming in on any of these media, they're able to grab that, and based on the words that are there in the news, they are able to categorize them on an automated basis, right? So this is the beauty of a machine learning, and that makes the job of the human a lot easier to glean the value from the data and create the value for the customer, create the ease for the customer, create the customer satisfaction, get them more engaged, and so on and so forth, right? So that's basically a quick view of what all is possible. Within the machine learning, there is a field called deep learning. And deep learning is being motivated by what we call as the neurons, right? So as I mean, the human brain is nothing but driven by neurons. I mean, I don't know whether I have spelled it correctly or not. That is basically the moment you touch a hot surface, right? Or something which is different from the body temperature, your instant reaction of the body reflex is to pull back your hand, right? You don't know how it is working. You don't know what exactly is happening inside your brain, inside the signals the brain is generating and sending to the body part and all of that. But it is being driven by this central processing unit, right, which is our brain. And it is being driven by millions and millions of neurons, right? So deep learning sort of like tries to leverage the same thing, where you will have, neurons sort of like, in different layers. And each of these layers are passing on the messages and the signals to each other and so on and so forth. And they will be sort of like, generating the output for you, right? So that is the main focus for deep learning. And as you would have seen, in the public media, people are now talking about the driverless car, right? Or the computer vision, right? And stuff like that. Or a robot which can do the household chores and stuff like that, right? They are most likely being fed by a deep learning network, which basically processes the image or the unstructured data coming in and then able to generate the output, right? And able to do certain actions and so on and so forth. So that is a very, very niche field. It is a subset of machine learning. Machine learning in turn is a subset of artificial intelligence, or the broad umbrella is artificial intelligence. And we as data scientists cut across the different fields. So you could be doing deep learning, you could be doing machine learning, you could be doing something which is not supervised learning, something which is not directly machine learning, deep learning, but comes under the broader umbrella of the artificial intelligence, right? So that's briefly about that. Like I said, I mean, I'm sure you guys would have a question. We will, give you opportunity to ask towards the end. So how is it that a typical data science project really work out, right? Just like any other business projects, any other area, we have different stages to it. the most important part is that you have to understand what is it that you're actually trying to solve for. What is the business problem, right? Then compared to the business problem, you have to obtain the data. So for example, let's make up a business problem, right? So let's say the business problem is that you're trying to find out why employees are leaving a company. Let's say I'm looking at a big company, big technology company, and they have seen that my attrition rate, which used to be 12%, is now jumping up to be 22%. I'm just making up some numbers to really give you context, right? So your business problem is that you're trying to understand what is it that is causing the employees to leave the company more, right? Given that business problem, given what you understand about that, you will have to sit down with the stakeholders to really understand a little bit more. Maybe you'll have to spend time with the employees who are leaving, do the exit survey, so on and so forth, to really get a better context of what exactly it is, right? That is how you'll collect your data, right? So data may be coming in from the external sources. So for example, there's nothing wrong with the company, for example, but there are some other new companies, some startups, which are actually offering them significantly higher salary or significantly better perks and so on and so forth. And that's why people are actually moving on, right? So you have to really holistically collect all the data that is required for you to really understand the problem and then say what exactly is it that is causing it and all the possible levers for explaining the business problem, right? In the next step, what we do is basically we begin with the data visualization or visualize the data. We do what we call as EDA also, exploratory data analysis, right? To really understand the data pattern, similarities, the plottings and so on and so forth. And then once you really understand what are the correlations among the different variables, how they might be impacting each other, then that is when you actually deploy the machine learning and deep learning models. Once you've done it, you actually draw the insights and actionables from it, right? So ultimately you have a model which is doing a fantastic job. So for example, if 15 people have left the company, your model is able to tell exactly the same reasons why they have left. And not only that, it will also help you make the prediction in the future, and which we'll be covering in the next slide, is to say not only when employee has left, I'm able to explain, but I can potentially tell you which are the employees who are more likely to leave the company, right? So draw the insights and actionables. And last but not least is the most important part is basically how do you tell the story? How do you tell the story to your stakeholders? You may have done a fantastic job in understanding the business problem. You may have done a fantastic job in doing all the remaining steps in terms of getting the data, doing the analysis, building the models, and so on and so forth. But you have to convince your stakeholders. You have to tell a story that people are willing to buy. People can correlate to that, right? And then they are willing to take some actionables based on that. So that is the last part, but very, very important, which is the storytelling and the, sort of like stakeholders buy-in. So if you want to be successful as a data scientist, all of these steps are equally important, right? So I cannot say only machine learning is what is important, or only storytelling and the presentation skills are important, or only working with the data is the important thing. You have to do all of these things equally well down the road to be very, very effective in this field, right? Now, you may have a question that, okay, so you have 50 analysts who are working in your team in Cabbage. Do all 50 of these analysts have the same skills in each of these areas? Obviously, the answer is no. So you may have people who are actually doing a fantastic job in storytelling. You may have people who are very good at the machine learning, but net, you should have some combination of these skills that you're actually embedding in yourself, right? All right, so with that, let's keep going forward. So generally, we break down the type of analytics into 4 main areas, and each of these areas are very important. So the first part is what we call as a descriptive analytics, right? And you're trying to say what has happened, right? And I'll give you some certain examples. So for example, the sales of an e-commerce company has gone down in last year, right? So let's say Amazon or Flipkart or any of these companies that you can think about, you're saying the sales of the company has gone down. So all you're doing is you're answering the what question. So what has happened? Sales has gone down, right? Or let's take an example to ourselves in terms of the health, right? So for example, if you're running a fever, and when you put a thermometer, you diagnose that, I have a fever. That is what the descriptive analytics boils down to. So you're just talking about the facts There is nothing that you're predicting. You're just stating the facts. Sales has gone down, body temperature has gone higher, more employees have left the company, competitive pressure is getting bigger, and so on and so forth. But you're just talking about the facts, right? Then the second question that you have to answer is why it has happened. Now, this is where you may come out with different hypotheses or possible ways of explaining that, right? Let's go back to the same example of the sales of an e-commerce company is going down. So now you may have potential reasons. So you may say, okay, I think the sales could have gone down because we did not advertise enough in certain media, right? So let's say Facebook or TV and so on and so forth. So now you're not just stating that something has happened, you're also trying to figure out why it may have happened. And that's what the diagnostic analysis sort of like boils down to. You're saying why it has happened, right? The why question is very, very important and very, very pertinent for any business problem solving, right? The third area is that, okay, not only you can tell what has happened and why it has happened, but what may happen in the future also, which is the example I was talking about, that there are 15 employees who left the company. That was the descriptive statistics. Why they left the company? 4 of those employees left because they were not happy with the salary. 3 of those employees left because they were not happy with their boss and blah, blah, blah. That is the why part, right? Now, in the last part, you're saying, okay, what may happen? Who are the employees who are at the risk of leaving the company? And that is what we call as the predictive analytics. You're making a prediction about what may happen in the future, right? And that's very, very important, because now you're going to be sort of like a future teller to tell, what is it that we will be seeing happening in the portfolio and so on and so forth. And that is one of the key role for a data analytics professional or data scientist to tell what may happen in the future. And then last part, which is very, very sort of like, important, but you cannot do this until you do these, is the prescriptive analytics, which is you're thinking more like a consultant. You're saying, okay, not only I'm going to tell you what has happened, why it has happened, and what may happen, but I'm also going to tell you what is it that we should be doing. So now going back to the example of employees leaving the company, you can say, okay, these people left, this is why they left, this is who may be leaving, and this is what you should be doing. So set up more one-on-ones, or do some competitive benchmarking, think about the salary increases and so on and so forth, right? And you basically intervene and you try to sort of like alleviate the problem or help the problem in terms of solution, right? So these are the 4 pillars of the data analytics, guys. And you will be doing some combination of any of these. So it's not necessary that you as a data scientist do all 4 of them. So maybe what you do is you just report the facts. So you're part of a reporting team where you're using tools like Tableau or ClickView and so on and so forth. And you're analyzing the data and you're just stating, boss, this is what has happened in the past 1 year, or past 1 month, or past 1 week, or past 1 day, and so on and so forth. You're just stating the facts. And that's where, some people call it more as a reporting job, right? You're just reporting what you are finding. Very, very important. It's sort of like, you can think about it's like a pyramid, right? And in the pyramid, the bottom of the pyramid, which is the foundation of the pyramid, is you must know what has happened. And then why it has happened. Then what could happen, and then you coming at the top of the pyramid is what is it that we should be doing, right? So I think that gives you some context of the different types of analytics which are involved and how do we look at it, right? Here are some of the examples. So I'll give you guys maybe a minute to take a look at this. And some of these terms may be very, very technical for you. So just take a minute and then I will explain some of them, maybe not all of them, and how the data science is being used in different industries. Okay, so I think you got an opportunity to just take a look at this slide to give you certain examples, right? So when you go to Amazon, they will say customers who bought this also bought this, right? Or people who bought this product also viewed these products, right? And they're actually using what we call as a recommendation engine to really generate the sales, right? And they are doing what we call as the upsell and cross-sell, right? So if you buy a phone, they're also saying, with the phone, you should also buy a glass cover. And with this, you should also buy, a power bank or something of that nature, right? So these are all being driven by the machine learning and the models that we have. I obviously talked about the default model that the bank will be using to really figure out whether I should give you a loan or not, right? You may have experienced this or you may not have experienced this, the fraud, right? So suddenly, let's say you make purchases of, I don't know, let's say, around 25,000 rupees per month on your credit card, and the maximum transaction size that you have on your credit card is 5,000 rupees, right? The moment you have a transaction coming in for, let's say, 50,000, or you have, swiped your card in Dubai, right? Or you've swiped your card in Sri Lanka, right? Immediately you'll get a call from the customer service saying that, hey, we noticed some suspicious activities on your card. Just wanting to make sure that it is indeed you who is transacting and not somebody else, right? So those are all being driven by the machine learning engines, right? So what we call them technically as the anomaly detection, right? Or something which is not a normal thing for you. The normal thing for you is that if I'm living in Bangalore, most of my transactions will be happening in Bangalore or at max, somewhere in India. I have never traveled to, let's say, a country in Africa, right? And suddenly you're seeing a transaction coming in from Sudan. And most of my transactions happen in the daytime. Let's say, I transact between 6 a.m. to 9 p.m. And suddenly they are finding a transaction happening at 1:30 a.m. from Sudan, right? So obviously these are the warning signals, but there's no human sitting and saying, hey, I'm finding something suspicious over here, right? There are humans backing up the machine, but the machines themselves are generating the alert, right? So imagine you're in a room full of lights. Suddenly the red light will start to blink that there's a problem over here. Human will get involved, and then they'll say, okay, probably I need to intimate the customer in terms of what is happening, right? Epidemic forecasting, like any type of virus, which direction they're gonna go, how many people will be impacted, where should we have the antibiotics, all of that is being driven by this. So this is an example coming in from the pharma world. A/B testing. A/B testing is nothing but a design of experiment. When you log into a website, they may have different interfaces, they may have different color schemas, they may have different font sizes, different, many different attributes of the website. Because they don't know which one is it that the customer will like, they are actually doing a live testing, collecting the data and then figuring out what makes sense, right? I talked about the customer churn strategies, earlier for the telecom. There are many other examples that we can go through, right? So I hope this gives you some context across the different industries where they are using the data science and what is the value that they're coming out with, right? So what does it take to be successful in data science, right? And there is no particular order. All of them are important, and I will point to one more article which I have written for a magazine, which I have shared on my LinkedIn as well. So you need to have a passion for learning, right? And this is a field where things sort of like evolve over a period of time. So you need to have a passion for learning. So I'm sure most of you would not be knowing any of the programming languages or any of the skills in terms of the statistical skills or math skills and so on and so forth. But believe it or not, nobody knew from day one. We all learned it, right? And we all keep on learning. So I keep on, highlighting this example from my own journey so far. So when I actually went into this field in 1999, I began with a language called SAS, right? Because that was what people were using at that point of time. So I was good for the next 5 years or so. And I thought, okay, probably I don't have to learn anything else. Then comes a new language, or not a new language, but becoming more popular at that time, R. So then I used R for about 5 years or so. And then I said, okay, I'm all sorted out. I don't have to learn anything new. Then comes Python, which obviously is, mainstream as of now. And I've been using Python. So the bottom line is that even though I have, almost 18 years of experience, I keep on learning every day. There are new techniques, there are new tools, there are new languages which keep on evolving. So if you miss the bus on SAS, you don't have to learn SAS. You can directly jump on Python. If you miss the bus on R, you don't have to worry about it. You can directly jump on Python, right? And whatever is next. I cannot foretell the future, what may happen in the future. So, but that is the main idea, that you have to keep on learning and evolving, right? Coding skills is required for a large extent. But there are tools nowadays where you don't have to be doing a lot of coding on your own, and you can still generate the machine learning models. Some of them, something like H2O.ai, you can look up later on, is a great tool There is data breaks, free tools, right, where you just point to the data and you can actually build a model right away, right? But nevertheless, programming skills, at least one language you should be having very, very good command over, right? Structured thinking process, how to take a problem and break it down structurally and then go layer by layer to attack that is very, very important. Obviously, your statistical knowledge, the love for numbers and passion for solving the problems is also very important. And at this point of time, I will take a segue and draw your attention to one article that I have written recently. And it's all there on my LinkedIn, so you can feel free to connect with me and find these information over there. So it's all public information. So the one that I was looking at is what does it take for you to be very, very successful? And I have mentioned some of the free courses and stuff like that. And, obviously we have Harish from Praxis. He'll be more than happy to, give you some context towards the end. So what I have done is, in a nutshell, I've tried to summarize what does it take for you to be successful, right? And I'll just give you guys a moment to take a look at it very quickly. So first of all, we are living in a data age where the amount of data that is available is exploding. It is following what we call as a Moore's law, that every 2 years, the amount of data that we have in the system is going to double, right? So most of the data that we have as of now has been generated in the last few years. So all the businesses are making a decision based on the data that they're having. Intuition is good, but data is better. And intuition backed with the data or data backed with the intuition is even better than either one of them, right? So a lot of people, and I have seen people with 15, 17 years of experiences, people like some of you who have taken a break and coming back, and they have done phenomenally well in terms of building their career in data science. So what is it that they have in terms of the secret sauce, right? And that is what I'm going to highlight over here. So the first thing, as I mentioned earlier in my discussion, is that you need to be a problem solver, right? You like to solve the problems. You should not be somebody who does not like to work with the numbers. I mean, that is what is required. Coding skills is another area that you should be focusing on. Consulting skills, so you should not be just a coder, right? That I can do very good programming in C++ and Java. You can be a business consultant, right? And you can be equally comfortable in a boardroom presenting the ideas as you are comfortable working with a group of analysts, right? And lifelong learner, as we talked about this. Sorry, the fifth area is the presentation, the storytelling skills, and the lifelong learner, right? So something similar to what I showed you earlier in the slide, but this probably gives you a better context on what is it that we can do. So you can take a look later on. I also have done a lot of typings and the articles in Quora. So I'll point you there. I'll share these links with you later on. So you can look me up, so Quora.com, and you can search for, okay, so let me just. So you can find like some of your questions that you may have. I have already tried to answer it over there, and hopefully you'll find some context coming in from there. So this is what I have been sharing with my students earlier on and people who read some of the things I have to write. So for example, if you're saying, where do I start, right? Or what do I do? Or how do I select this? Or anything of that nature, any generic question, this may not be a bad forum for you to just take it out for a spin and see whether there is some questions that I can answer you over there, right? So it's all there. You can look me up on Quora as well. You obviously have my LinkedIn profile. I'll share the links towards the end. Let me now, in interest of time, come back to the presentation and finish up my talk and then open up for Q&A. Right? So nowadays, even people who are working on Excel are calling themselves as a data scientist, right? So it's because it's so popular, that's what makes it very abused term as well, right? So anybody and everybody who is doing remotely anything to do with the data, they are calling themselves as a data scientist. So what does it take for you to become a true data scientist in all seriousness? So some of these areas are highlighted over there, right? So you should have statistical knowledge, should have done significant amount of coding on your own, and presentation work experience, as we discussed earlier on. So I was saying, guys, that why is it that we should worry about the data science and what exactly is it that it offers us? The short answer to this question is the jobs, right? And jobs not just only in US or India or Singapore or Britain, jobs everywhere and in every industry. So there's no industry which will say, no, 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 I don't need a data scientist, right? If they're doing that, they will not survive for long. So it's becoming as common as learning the computer and the Microsoft Office in the early 21st century, right? So imagine when you are actually sitting in 98, 99, 2000, not everybody knew how to work on a computer, right? And most of them, they thought, okay, they don't have to learn it. But now we know what is the situation. So it becomes more like a hygiene factor for you. So if you have team members who are talking more in terms of the data science lingo, or if you have a manager who is talking in terms of the data science lingo, and you have no clue of what they're talking about, you'll be at a very, very disadvantaged position, right? So either you continue in what you're doing as of now, or you want to get in a data science field afresh, or you want to make a transition, or whatever combinations that you're looking at, you must know data science is what my personal advice to all of you is. And obviously the jobs is an added motivator behind that, right? This is another, research or the, report coming in from a couple of different sources. By 2021, AI will support 80% of the emerging technologies, right? So if you're thinking about, Alexa from Amazon, right? Or the Google Assistant, right? Or your phone, or the car, right? So MG Hector is coming out with this smart car, sort of like a smart car, right? So you'll see more and more of your day-to-day activities are going to be driven by the AI, and AI is a broad umbrella term for anything to do with the data science and so on and so forth. We will have obviously a scarcity of some key talent. Again, based on the statistics, it says 2.3 million jobs, and 50% of the organizations will not have the talent that they require, right? So I teach a lot. I teach obviously in Praxis and other schools, and a lot of my students have 15, 20, 25 years of experience, and they have been doing certain things. And some of the people were coming in from the unrelated industries also, right? Or unrelated field completely from the data science. And they were able to, after a lot of hard work and passion and grit and participation, they were able to actually go forward in their careers, right? So, obviously the need is there, but it doesn't mean that everybody who says I'm a data scientist is going to get a job right away, right? So you have to have the talent and the skills and things that we talked about earlier to be able to grab those opportunities. The opportunity will be there, but it doesn't guarantee that you can be just, getting in those opportunities right away. So it does take significant amount of effort on your own side, right? Okay, so let's keep going forward. I have mentioned some of these things, but probably it's too early for you. There are tons of publicly available data where you can actually go and try to get your hands dirty in terms of playing with that data and then building something on that, right? What are some of the most common mistakes that people make in becoming a successful data scientist? They think just knowing the coding and the algorithms is going to solve the problem for them. Absolutely not. You have to first think like a business owner, and the business problem has to be 100% clear to you before you move on. Not following the structured thought process, right? And there are obviously some frameworks that you can look up on my LinkedIn profile, which will help you. Analysis paralysis, because you're data driven, you will always like to get more and more data. And that obviously is the problem of another magnitude on a different extreme, right? Poor communication and unnecessarily complex solutions, right? So, if something can be done in Excel, you don't have to deploy Python. If something can be done using a simple linear regression model, you don't have to deploy the deep learning, right? And so on and so forth. So there are places where you need a needle. There are places where you need a sword. You cannot just say, because I have sword, now I'm going to stitch my cloth with the sword. You still need a needle, a small tool, right? And so on and so forth. So guys, this was what I wanted to cover from my side. So hopefully that gave you some context. I want to open up for Q&A, and Harish, if you like to jump in and would like to talk about the program, feel free to do that. Otherwise, we can open up for the Q&A from the people.
Hi, I am also available here. So if so first I think we should allow people if they have any questions, okay, and then we could, or maybe I could also take them through a small presentation. What would you suggest, Tina?
Okay. Yeah. So let's
open up for questions.
definitely.
Anybody has questions, please type it out on the chat window, or you can raise your hands and we'll unmute you and you can go ahead and ask your questions. I think
Definitely.
we had a few in the beginning. They wanted the link to the presentation, Mr. Pandey. Would you
Sure.
be sharing it?
Yeah. I'll be sending the presentation link in a minute. So I'm just putting all the links that I've referred to. So just a minute. I've shared
Yes.
my LinkedIn profile, my Quora profile.
Deepan Vita Datta, you have the links to the presentation. And plus, we'll be editing this webinar and sharing the link on YouTube.
Great.
Yes.
So I put my blog as well, guys. The link for my blog. I have my own blog where you can read some of the techniques and some of the things. And if you want to start with Python, you can find those links over there. And let me just dig up the presentation link very quickly, and I'll share that as well. Okay.
We have a question from Jaswini Mohanty. What are the companies that hire women as data scientists?
Okay. The short answer, Jasmine, is that all of them. And in fact, if I talk about my company that I'm working for as of now, Cambridge, we have been given a mandate by the senior folks in the US to bring in more women employees, right? I will go to the extent that if I have women and men prospects and they are both equal, we will probably give preference to women in getting them on board. So there's a huge push to hire more women data scientists, and this field is growing across a different board, across different industries, right?
And we have another one from Ankita, who wanted to check what is neural network.
Yeah, neural network, Ankita, is the one that I mentioned earlier. It's the data science driven by the deep learning, right? So if you come down in my link, in my Quora blog, you'll find that over there. It's nothing but how we will actually have a human brain answer the question, driven by neurons, right? Neurons are part of the neural network, and that is what a neural network is. So I will try to share a link with you so you can read up later on. But it's all related to what we talked about, that when you are not, for example, this link which is there, right? I'll put the link out there. You can read, you can go through it to really understand. But neural network is part of the deep learning. So when you have many layers in a neural network, that becomes a deep learning, right? So you can find more information there. Great. Other questions?
Yeah, we have here Ashpal is raised a hand. Please go ahead and ask your question here. Please go ahead.
Hello. Yeah, can you hear me?
Yeah.
Yeah, we can hear you.
So I had one question. I have 8 years in testing. So how do I transfer my old experience to data science? Or do I need to start off as a fresher, or how do I go about using my old experience as well?
That's right.
Ratnakar?
That's right. Yeah. So great question here. I think a lot of people who come to the industry, the data science industry, they're coming in from freshers from the college, right? They're coming in from an experience and certain background. I think the best thing for you to do, and for anybody in that position, find opportunities which leverage your experience in the testing world, and then you're adding on top of that a layer which talks about in terms of the data science, right? So, for example, I have seen a lot of people now building predictive model within the testing area, right?
Okay.
What tools and what softwares and so on and so forth will be going in and having the problems that their area. Having said that, you can go and work in a very area altogether as well. So it doesn't necessarily have to, but it's always advisable that you leverage years of experience and build on it, right? Because that becomes the core. You understand more about that area, right?
Right.
So that is what my advice would be. That always have the core competence, and then you're picking up the new skills. New skills in this case, the data science, right?
Right. So basically applying data science in testing area, you're saying.
Exactly, exactly.
Okay. Or we could also start afresh, like you mentioned, right?
That's
Start
right. That's
afresh
right.
fully in data science, right?
That's exactly right. Yeah.
Would that mean I have to obviously step down a bit? I mean, join at a fresher role if I have to completely move to data science? Not in
Yeah,
testing?
I wouldn't call that as a fresher because people do give weightage to your experience that you have been doing so far. I mean, if anything,
Right. Okay.
80% of what makes you successful in an organization is your soft skills, right? So I think you already been in the
Right.
system for that long, so on and so forth. So obviously, there's a weightage that will be coming for the experience that you have.
Okay. Right, Ratnakar. Thank you so much.
Sure.
Thanks a lot. Yeah.
Yes. Let's move on to the next question. We have one from Asma Ara. She asks, what is a step-by-step process to enter into analytics and expertise? Can you let us know about your entrance and transformation into analytics field?
Okay. So in my case, so you said, sorry, I didn't get Archana or somebody.
Asma Ara.
Yeah, yeah. So Asma, in my case, I mean, unfortunately, I started my career in the field. So I only worked for 6 months in Tata Motors in an unrelated field. But then when I went to the US to get my master's degree, I knew that something related to data is what I will be doing. So I've been doing that from day one. I've been doing the data science from the time when it wasn't even called a data science or analytics or anything of that nature. So it wasn't that glorified a field, but I was doing number crunching from day one. Having said that, most of you guys do not fit that criteria. So in your case, it will be good to really go and have a discussion with different people that you know of, right? See what exactly are the things that they're doing. What are try some free courses, try talking to people like, I mean, Harish from Praxis will give you certain context, right? So because most of the guys who are coming to the schools, they come in with absolutely no background in the field, right? And then they make a call whether this is the right program or they should forward in this career and so on and so forth, right? So you have to start by talking to the people who are from the industry, either working to bring more people in the industry, or they are practitioner of what they are working on and so on and so forth. So those will be the first places to start.
We have another one from Miss Tata. She wants to know, she apparently has about 8 years of experience in database management. How can she transition to data science?
I think it's very, very related field. If you already have experience in the database management, right? Most of the times for being successful as a data scientist, you have to really know what is the data that you are actually working on. It's from Deepanvita, you said?
Deepanvita Datta.
Yeah, Deepanvita. So, I mean, your experience will be very, very relevant, Deepanvita, in my opinion, because you already know where exactly the data is coming in from, how exactly are we storing it, how to do the ETL, how to take the data forward and create data lakes, the entire agile framework, and so on and so forth. So, I think it's very, very related. It'll be very hard for you to sort of build up on this skill and get more comfortable.
Okay, we have a similar question, but from Priya. How far it's safe to switch from an non-IT background to IT? As a non-IT person a non-IT person will not have neither coding nor programming knowledge. Can they get equal chances like IT professionals?
Yeah, and it depends on how many years of experience you have. So I have seen people coming in from very, very unrelated field, people coming in from the ceramics background, for example, people coming in from telecom background, people coming in where they were installing or fixing things in the telecom towers and stuff like that, right? So many different areas are possible. So it's not really a rocket science to say, getting into this field, right? But obviously, I have mentioned earlier that if you just think because the courses, people are going to roll out a red carpet for you and they will open up and in terms of get you in, you have to go through a journey. You have to be very persistent. You have to be very, very, passionate about this field. And you have to be very clear in terms of the priorities that you have in your life. It is all possible, but it will take some added efforts if you don't have any sort of coding experience earlier on. But having said that, it is entirely possible.
We have the next question from Tulsi Rao. She wants to know particulars about a course for Java developers, automation engineer.
I don't have background Tulsi in Java, but if you have already done Java or any sort of automation, stuff like that, they're all related, right? So they should all help you. Any sort of coding, any sort of logical thinking, any sort of business context that you have, or problem solving that you have done in the past, or if it is not even related to any of those, you have been working in a particular area for 4, 5, 10 years, even the area that you're working in will require the data science skills.
The next one is from Ankita. She wants to check what are the opportunities as a fresher, as she has about 4 years of experience in HR recruitment and now on a maternity break for the last 2.5 years. She wants to change her career from HR to data science. How should she go about it?
Yeah, so I think there are a lot of, I mean, within the HR field also, Ankita, there's a lot of need, and there are, courses which are specifically targeting the HR analytics, right? Because HR traditionally has been the last area where people have adopted the data science, because the people are driven a lot by the intuition and so on and so forth. Now we are looking in a situation where HR folks and the people operations team in different companies are leveraging the data science to a maximum extent, right? There are specifically designed courses for the HR analytics people and so on and so forth. So your background will tremendously be of great help, or will be a tremendous help in terms of you migrating into a data role.
Okay. The next one is from Rati Shri. She's an MBA in finance, worked in management consulting and audit areas. She's also certified in a course in software programming. What would be her future? What would be the future if she transitions to data science, and would it be a wise move?
I think, like I said earlier, anybody and everybody should know data science, in my opinion. It's as simple as that. So I think even if you're not doing or leveraging it right now, very soon you'll be in a requirement that you have to do something about that, right? Just go back to the point I was saying, that imagine you not being able to operate on Excel, on, when I say you, somebody else who was there and working in a professional world at that point, in 2000 or 2001, they did not know Excel, for example, right? Will they be able to survive? Will they be able to survive if they do not know PowerPoint or Word and so on and so forth? Probably to a certain extent, but if they have to be very, very successful, these are skills that you must have.
Yes. The next one is from Neeta. She's a C+ developer with 10+ years of experience. She wants to switch to data science. Domains that she has worked for is network security and antivirus development.
Yep. Like I said, I mean, any domain and all domain, I mean, people are open, and I think any domain and all domain, they will be requiring the data science people. The term that people are coining nowadays, they are calling as, you can see my screen, they're calling them as citizen data scientist. So what does it mean is basically, you don't have to be having, certain pedigree or certain coding experience and so on and so forth. If you know what you're talking about from your domain experience, there are tools and softwares which are available, which at a fraction of effort will make you very, very effective for the role that you're playing within the team, right? Rather than hiring, big team of data scientists from out there, people are also tapping the current employee base and bringing them up to a certain speed and saying, can you guys take it forward from over here, right? So some more context. So if I look at, how much time would I take to build an algorithm 5 years back, same algorithm can be developed in, I'll say, probably 1/4 of the time, right? So things are becoming more automated, things are becoming more easy for all of us to operate in. So I think that will be very, very helpful for the people who do not have the background. You don't have to be working that hard as we used to work earlier to build up the expertise in this. Right?
Okay, we have Ashwini asking. She has Python and EDA techniques that she's learned. With that skills alone, what type of job will I get in data science domain?
So the coding skills is absolutely a must-have. So if you already have done EDA and Python, great job. I think the first place that you should start with, the reporting, dashboarding, and the data manipulation, data munging, and ETL, and those sort of opportunities, right? But I think, I mean, if you have already done the coding, you have already done the hard part, you can actually then try to become a little bit more statistically savvy as well, if you prefer to.
Okay. And then we've Harsha Singh, who's in the banking domain. It is predictive analytics more needed. Is predictive analysis more needed or diagnostic analytics? Like anything that holds a greater weight?
I would say probably all of them are important. So if you remember the pyramid that we talked about, right? So the bottom layer is your descriptive, right? The next layer is diagnostic and so on and so forth. You have to be doing a thorough job in terms of understanding the data, right? So they're all equally important. More team members will be working in the bottom of the pyramid because we need to really spend more time understanding what we are actually finding in the bottom.
Okay. And then there's Jasmeet Kaur, who says she's an IT trainer and want to switch data science profile. Want to switch to a data science profile. She has about 8 years of experience. Are there any chances that I can get industry offer, as I have only experience in academics?
Within the academics also, Jasmeet, you may have opportunities, but I think I'll have to see what exactly your experience contour is. But I think you can build on whatever you have done, right? So that is not really a very difficult thing. It will not happen overnight. You'll have to spend time and effort and be very persistent. And don't quit your day job just yet. I'll say probably, you should learn a little bit more, and then you can make a call on what exactly is it that you're looking at. So just a quick time check, guys. So I have,
yes,
2 more
we
minutes.
we have about 14 questions more, 15 now. So how would we take it? Should we ask them to mail it to us, and can we take it later, Mr. Pandey, or can you answer it now?
I can do that, and I think a lot of these questions can be picked up by Harish as well. So unfortunately, I have to run in the next 5 minutes for a meeting.
Yeah, definitely. So all of you whose questions are not answered, please, you can email me on this ID that I'm giving you, or you can contact Mr. Harish, who is here with us today. Harish, it'll be nice if you can share your email ID and other details. Okay. Python is the current go-to programming language for data scientists these days. Is there any other language which you advocate?
No, I think my suggestion will be, guys, don't try to spread yourself too thin. Focus on one thing, but do it very well, right? And when I said SAS and R, it's not like that SAS and R, they're not being used, right? So if you know R very well, you'll be hired, for example, in my team, right? If you know Python very well, you'll be hired. Doesn't matter. So it's not about the spread or the width of the knowledge that you have. It's more about the depth of the knowledge that you have, right? So you have to really make sure whatever you know it very well.
And then we have similar questions that you have answered, Mr. Pandey. So I think let's stop at this, and then probably people who have questions can come back to us with, can send it out to us on an email ID, and we'll answer it for you. Yeah. Thank you, Mr. Pandey. This was very informative. We will need to find an opportunity in every way possible. Opportunity can be extremely different from what you've done earlier. Request each one of you to believe in yourselves and take that first step to upskill, to restart and rise in your careers. Praxis will definitely help you in all of this. Please contact Mr. Harish and you will get your answers.
Definitely.
Thank you, Mr. Pandey. Definitely very, very informative.
Cool. So Harish, over to you. I will drop off now. And
yes. Thank you for your time, Mr. Pandey.
We'll be more than happy to help you out. Thank you.
Yes.